A circumference is the length of the edge around a circle. For any circle, the circumference is 3.141592. Diameter is a unique number. It is represented with a Greek letter pi. The diameter is the length of the line that touches 2 points in the edge of the circle, equivalent to the double of the radius, the distance between the center and the edge. A geometric locus of a conic section is the set of points that meet a given condition, are called locus. In a circle, the locus is the set points in a plane that are a certain distance from the central point, the radius. By connecting them, you can have a circumference. A circle is the set of points that are fixed distance from a specific point. Using the same distance to connect with different points, a circumference will be formed. The diameter is equal 2 times the radius. The radius is equals the range equals the diameter divided by 2. The center is h, k. The equation is x minus 1 elevated by 2 plus y minus 1 elevated by 2 equals r to the square. The domain is, to get the domain, it is needed to subtract and add the radius to h, and to get the range, it is needed to subtract and add the radius.
There are several real-life circumference application examples. These are roulette, car tire, steering wheel, ship's wheel, clocks, roller coasters, loops, and turbine blades. In this video, we're going to talk about 2 examples, the roller coaster loops and the turbine blades. First of all, the roller coaster loops. Even though the loops of a roller coaster are not actually concrete circles, when they are made by engineers, these engineers need to use the circumference formula because they need to calculate the centripetal force. Before calculating the force, the engineers need to get the circle and its properties, like diameter and radius. This is because the formula of the centripetal force consists of mass, velocity, and radius of the circle of the curve. The circumference and calculation of centripetal force are also used to create the curves of the streets.
The wind power has been used since the 11th century with the use of windmills, but in 1979 we created the big artifacts with spinning fans we all know. For us to be able to take 100% advantage of this green energy, many factors must be taken in account, and many of these include circumference and circles. The linear speed is basically the length traveled in a unit of time. If this number is really high, the production of energy will also be really high. Even though this might sound like a good thing, to be producing a lot of free energy, it can ruin the windmill. The speed is calculated by this formula, circumference divided by the unit of time. And by this, we can determine the length of the blade and make sure the windmill doesn't break.
Everything in the world is connected, and math has a great impact in our life. Every kind of math, either algebra, arithmetic, or any other type, has an influence in our daily basis. The last partial, we saw the ways exponential functions can reflect real-life situations, such as the population growth in a country. In this project, we see how conic sections, especially circumference, has an influence in products and situations in different branches, like medicine, engineering, and technology. By this project, we can see that all the topics that have been seen in class are useful and applied in real life, noticing that all our learnings can be useful at college and future projects.